Okay, now for the last lesson of this unit, equations of circles. If you are not very good with completing the square or the quadratic formula, you might want to practice that a little bit before you get started on this, and dust off the distance formula because we're going to be using it as well. These are the content standards and the mathematical practices that will be used in this lesson. Previously, you wrote equations of lines using information about their graphs. Now you're going to write the equation of a circle, and you're going to graph a circle in the coordinate plane. There is one new vocabulary word, compound locus. Since all points on a circle are equidistant from the center, you can find an equation of a circle by using the distance formula. And here's a key concept. The standard form of the equation of a circle with its center at HK, notice the H and the K, that represents the center of the circle, and radius R. The standard form of the equation of a circle is also called the center radius form. Okay, let's write an equation using the center and the radius. So we're given the equation, write the equation of a circle. We're given the center and its radius. Using the equation of a circle, we substitute in the H and the K and the R. And then simplify it, x minus 3, quantity squared. And the quantity y plus 3 squared is equal to 36. That was pretty easy, wasn't it? Okay, let's try another one. This time we're given the graph of the equation. What's the radius? There you go. So the center is at 1, 3, and its radius is at a 2. So substituting in the center and simplifying it. Okay, time for you to practice. So pause the video and write the equation of this circle and then come back and check your answer. Did you get C? X minus 2, y minus a negative 4 is y plus 4, and 4 squared is 16. Very good. You did so well. Let's try another one. This time from a graph. So pause the video, then come back in a moment and check your answer. Well, as you see, we've got a radius of 3, right? 1, 2, 3, 1, 2, 3. So we know we're going to have 3 squared, which is 9. X is going to be 0, or x plus 0 squared, so x squared, and then y minus 3 squared. The center is at 0, 3. Now we're going to write an equation using the center at a point. We're told that the center of this circle is negative 3, negative 2, and it passes through point 1, negative 2. So first of all, we need to find the distance between the points to determine the radius. So radius is 4. We pick the point has negative 3, negative 2 for HK, and the radius we found out is 4. So substitute in and simplify. Okay, time for you to check your progress on this one. So pause the video and determine what the equation would be, and come back and check your answer. Well, I used the distance formula. I found r is equal to the square root of 3 minus a negative 1 squared plus 0 minus 0 squared. So I end up with the square root of 4, and that will be 4. So 4 squared, you know your radius is going to be, your equation is going to have 16 here. Using this point, x minus a negative 1 squared, y minus 0 squared. So that just leaves you with the y squared here. Now we're going to graph circles. You can use the equation of a circle to graph it on the coordinate plane. To do so, you may need to write the equation in standard form first. Here we're given the equation of a circle, and that looks a little bit confusing, doesn't it? State the coordinates of the center and the measure of the radius, then graph the equation. First of all, we need to write it in standard form by completing the square. So if we look at the x portion, we've got 4, half of 4 is 2, and 2 squared is 4, so I add 4 to both sides. Now let's complete the square here with the y. Half of 6 is 3, and 3 squared is 9, and we add 9 to both sides. Now let's simplify a little bit. We can factor the x minus 4x plus 4 as x minus 2 squared, and we can factor y squared plus 6y plus 9 as y plus 3 squared, and negative 9 plus 4 plus 9 is 4. So we're writing the positive 3 as minus a negative 3. 4 is 2 squared, so that we can identify what the h, the k, and the r would be. So h is 2, y is negative 3, and the radius is 2. Time for you to check your progress. Which of the following is the graph of x squared plus y squared minus 10y equals 0? And again, you're going to need to know how to complete the square in order to solve this one. So pause the video and work out the problem, then come back and check your answer. So I didn't do anything to the x squared because I know that 0 is being added to it. But on the y, I take half of 10, which is 5, and square it. So you add 25 to both sides. When you factor, you've got x minus 0, quantity squared, plus y minus 5, quantity squared, is equal to 25. Because after you take half of b and square it, you have to add it to both sides. So now it's no longer equal to 0, equal to 25. When I rewrite it, I've got my point as 0 and 5, and my radius is 5. So B is my choice. In a real-world example, we're going to use 3 points to write an equation. Strategically located substations are extremely important in the transmission and distribution of a power company's electric supply. Suppose 3 substations are modeled by the points D, coordinates 3, 6, E, coordinates negative 1, 1, and F, coordinates 3, negative 4. Determine the location of a town equidistant from all 3 substations and write an equation for the circle. Well, you're given 3 points that lie on a circle, so let's graph triangle DEF. Then we'll construct the perpendicular bisectors of the 2 sides to locate the center, which is the location of the tower. Then find the length of the radius and use the center and radius to write an equation. So we graph triangle DEF, we construct perpendicular bisectors of the sides, and we find the point center C, and it appears to be at 4, 1. This is the location of the tower. Now we find R by using the distance formula with the center and any one of the 3 points. It doesn't matter which you choose. So we get a radius of square root of 26, and we leave this in the format squared. Square root of 26 squared is 26. The location of a town equidistant from all 3 substations is located at 4, 1, and the equation for the circle is x minus 4, y minus 1, both of those quantities squared, equals 26. You can verify the location of the center by finding the equations of the 2 bisectors and solving a system of equations. You can verify the radius by finding the distance between the center and another of the 3 points on the circle. So time to check your progress. So pause the video, read through the problem, and remember what you did on the last example in order to solve it, and then come back and check your answer. Did you get C? When I graphed my points at 0, 1, 4, 1, and 4, negative 3, did perpendicular bisector. The center of this circle is going to be at 2, negative 1. A line can intersect a circle in at most 2 points. You can find the points of intersection between a circle and a line by applying techniques used to find the intersection between 2 lines and techniques used to solve quadratic equations. And we're asked to find the points of intersection between this, which is the equation of a circle, and a linear equation. So graph these equations on the same coordinate plane. And you see there's one intersection point. You can estimate this point on the graph to be at negative 4, 4. Or you can use substitution to find the coordinates of this point algebraically. What you do is you substitute in, because this is the equation of the circle, x squared plus y squared equals 32, and you were told that y is equal to x plus 8, so you substitute in x plus 8 for y. And then evaluate, simplify. We're factoring out a 2 from every portion, from every term, and then we can factor x plus 4, quantity squared, is equal to 0. Take the square root of each side. So we're going to use y is equal to x plus 4 to find the corresponding y value. So we found that x is equal to negative 4. We substitute it into this equation and find that the y value is 4. So the point of intersection is negative 4, 4. Okay, the last check your progress. Time for you to graph the equation, this circle and this line, and find out intersection. Remember, at most there can be 2 intersection points. I solved this one by graphing, and I found that when I graphed both the linear equation and the equation for the circle, they intersect at negative 2, 2 and 2, negative 2. Very good. You're ready to begin working on the assignment.